So now it's actually time to look at the p orbitals. So with the s orbitals, we saw they were spherically symmetric. And we used those s orbitals to illustrate a lot of concepts, what we meant by a wave function, what we meant by probability density, what we meant by radial probability. But now we're going to look at the 2p wave functions. And the p wave functions, as you probably already know, are not spherically symmetric. We're going to use this dot density diagram again to represent the probability density for the p wave functions. And so I'm going to take the psi 210 wave function, and I'm going to square it to get the probability density. And then I'm going to plot the result of that in 3 dimensions. And the result is what I show you here. And of course, this is the typical pz orbital that you've all seen before. And what you see in the case of the pz state, or the pz wave function, is that the probability density is symmetric around this z-axis here. Most of that probability density is concentrated along the z-axis. And if you look very carefully, you can sort of see that there's no probability density here in this xy plane. Here's the px orbital. I'm plotting the probability density. That probability density is concentrated along the x-axis. It's symmetric along the x-axis. And if you look very carefully, you can see that there's no probability density in the yz plane. And then the py orbital. That probability density is concentrated along the y-axis. If you look very carefully, there's no probability density here in the xz plane.